In this problem, we need to find the coefficient of the x to the 0 power term in the expansion of the binomial x squared plus 1 over x, all raised to the 6th power. So first I want to locate which term in the expansion we're talking about. And this one is more complicated than what you usually see. Usually it's really easy to right away get to the term that you're talking about. But because there's x's in both of these, and we have in both of the terms that we're looking at, x squared and 1 over x, and the fact that we have an x squared that's in the numerator and an x in the denominator, that's going to wind up with some canceling, so which is of course what you need to get to the x to the 0 there. So this is a little bit more complicated. Usually x to the 0 would be either the very first term that you would get or the very last term. So let's take a look at this. And so what I'm going to do is I'm just going to not worry about the coefficients at the moment. So I'm going to just write coefficient times, and then we have x squared to the 6th times 1 over x to the 0. So make that a better 0. Okay, so I like to just throw this in because what I want to keep in mind is that my two exponents here always have to add up to 6. So I have 6 and 0, so I always have two of them. And a lot of times the book will just skip writing that 1 over x to the 0 power, which is fine in practice. But just I wanted to be really clear as to what was going on. Plus some other constant times x squared to the 5 times 1 over x to the 1. And again, adds up to 6. Plus constant times x squared to the 4 times 1 over x to the 2. And again, 4 and 2 adding up to 6. Plus constant, times x squared to the 3, 1 over x to the 3. Okay, so at this point, I'm going to check and see, and I can see already this is not going to simplify completely to just a constant, but just to kind of get an idea of where we're at. So we have x squared to the 3rd, which gives me x to the 6th, and that's multiplied by 1 over x to the 3rd power, which is 1 over x to the 3rd, and when you multiply those, you get x to the 3rd power. So we are getting smaller exponents for x, but we're not quite done yet. So I'm going to continue down here, plus some constant, x squared to the 2, 1 over x to the 4. And again, my exponents add up to 6. And when I say my exponents, I'm not including this x squared, right? So I'm just, this outer exponent have to add up to 6. And let's check again to see how we're doing with getting towards x to the 0 power. And we have x squared squared, that's x to the 4, and 1 over x to the 4, and here we go. So that is x to the 0 power, or just 1. So this is the term that we're concerned with. So we had 1, 2, 3, 4. This is the 5th term of the polynomial. So now I can figure out what the coefficient is, and I'll be done with the problem. So in order to figure this out, I'm going to use Pascal's triangle, because I could go to the calculator, but it's a lot easier for me to just draw this triangle really quick. So I'm going to go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And so what is the logic that I'm using here? It's that whenever I have two numbers adjacent to each other, then they're going to add, and I put that sum underneath in the middle of them. And so 2 and 1 make 3, and 3 and 3 make 6, and 1 and 3 make 4, and so on. So that's what I'm talking about with this triangle. And then I have 1, 5, 10, 10, 5, 1, almost there. We were working with this sixth power, so I need to go to the sixth row. And the first row is not really the first row, that's the 0th row. And we just don't count it, so just ignore it. So now we're at the sixth row. It's got a 6 in it right away, so that's a pretty good indication you're at the sixth row. 15, 6, and 1. Okay, so now I'm going to count. So we have 1, 2, 3, 4, 5. Here's my term that we're looking for. There's my coefficient. And so 15 is my coefficient of x to the 0 power. Now, if the question had asked for the total expansion, then I would give 1 times x squared to the 6th times 1 over x to the 0 plus 6 times x squared to the 5th times 1 over x to the 1. And I would simplify all those terms, keep going, and give that whole expansion. Here, this is the term, right? But what they asked for was the coefficient. So the coefficient is actually the 15. And do keep in mind that not in this problem, but in other problems, for example, if I had had 2x plus 3 to the 6th, and I wanted to expand this, then my first term is 2x, so I would start with 2x to the 6th power times 3 to the 0 power, coefficient. Well, we know what that is, right? That's coefficient of 1. We just found that. And then the next one would be 6. That's the next term in the Pascal's triangle. And then we'd have 2x to the 5th, 3 to the 1, plus, and keep going. And so what do we see is that the 2 and the 3 are going to affect the coefficient. So I would get 6 times 2 to the 5th is 32 times x to the 5, and 3 to the 1 is 3. So then I need to multiply 6 times 32 times 3, and I get 576 x to the 5th, which is my term, and the coefficient is 576. All right, so that's how you do that problem, and a little bit extra too.